Hello. Today we're going to start talking about trigonometry and the basics of trigonometry. Initially we're going to sort of look at our right triangle and start connecting it to the ratios that we have looked at within our class, such as opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So our objectives for today: students define sine, cosine, tangent of theta. Theta really is just a symbol representing an angle. Okay, it's a Greek letter that we oftentimes use Greek letters as it happens for our angles, and you're going to see them littered throughout a lot of the material upcoming. So where theta is the measure of an angle, of an acute angle of a right triangle, students denote sine, cosine, and tangent as, notice this. So sine, S-I-N-E, is written as just S-I-N. Cosine, just C-O-S. And tangent is just T-A-N, respectively. So that's an important takeaway also. If angle A is acute, whose measure of degrees is theta, then sine of angle A is the same thing as sine of theta. Cosine of angle A is the same thing as cosine theta, and tangent of A is equal to tangent of theta. All right, some of the vocabulary you may see is right triangle, right angle, acute angle, opposite side, adjacent side, hypotenuse, and similar triangles. Okay, so that's just our foundation for what we're going to learn today. As we look at this, we have been investigating again these three ratios: opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. All right, and normally these fractional expressions are said to be values of ratios. However, it gets really redundant if we have to say the value of the ratio of opposite to hypotenuse is, and so we kind of simplify them in terms of these sine, cosine, and tangent. All right, and so if I'm here and I want to strictly define what the sine is, first thing we have to have is theta is the measure of an angle A, as shown in this. Okay, and one of the suggestions I have is that you draw a little person around whatever your reference angle is. And why do I do that? Because my person looks opposite, and that just reminds me of where the opposite side is. And a lot of textbooks and a lot of things will write opposite as just OPP. They'll write adjacent as ADJ. But really you want adjacent, and the last one is hypotenuse. And so now that you're somewhat familiar with the shorthand that we use within these, sine would be opposite over your hypotenuse. Your cosine is your adjacent over your hypotenuse. And finally, tangent is opposite over adjacent. Again, you may see these written differently. Just OPP over HYP. You might see ADJ over HYP and OPP over ADJ. So those are very common shorthands for what you're working with. All right. Moving on, there are actually more trigonometric ratios. There's 6 total, so 6 total trig ratios. All right. And what happens is we start looking at them with much more depth as we begin to feel more and more confident, but they switch. So secant is the adjacent over the hypotenuse. So this is the reciprocal of cosine. Cosecant is the reciprocal of sine, and then opposite over adjacent is reciprocal of tangent. We are not looking to understand these specific ratios in this course, but I just wanted you to become familiar with them or know that they're there. Okay, so here's our practice. In the triangle, measure of angle A is 33.7 degrees, measure of angle B is 56 3/10 degrees. Complete the following table. Again, I really do highly suggest that you go through and you make your little man or woman, and that person looks across, and that just helps you sort of identify, here's your opposite, here's my adjacent, here's my hypotenuse. And next to each of the trig functions, you really want to write down every single time what the ratio is. It just helps make you more organized and follow through what they're being asked. And so if I think about this, 33, I've gone across from it, I have my opposite. So opposite would be 2, the hypotenuse is square root of 13. There is a rule that we really should rationalize this, so 2 square root of 13 over 13. That becomes a little bit monotonous as we get further and further into trig and we're using more and more square roots. So there are times where people will just leave it not rationalized. Cosine, adjacent over hypotenuse. So the adjacent is 3 over square root 13, and the tangent would be opposite, which is 2 over the adjacent, which is 3. Now, here's what makes these additionally difficult, is when they change the angle on you, you have to relabel all this. So adjacent goes away, opposite goes away, and now my little man or woman is here at B, and I have to rewrite these. So this becomes my opposite, this becomes my adjacent. And so that's something to take away as we go through there. There's patterns within this, and it has to do with whatever your reference angle is. And so when you're looking at these, my sine could now be 3 over square root 13, and that's because I'm looking at a different reference angle. But notice there's a connection, and we'll talk about that connection in further detail. That's not the point of this video. And then you could have adjacent, which is now again in a different spot. So this would be 2 over 13 square rooted. And finally, we have 3 halves. Okay, so that takes a little bit of time. You have to be able to be flexible with whatever reference angle they're asking of you, and so colors really does help. All right, so here now we're looking at angle D and E, and so let me just go through this. Draw my little person in there. They look across, so here's my opposite, here's my adjacent, and here's my hypotenuse. And notice your hypotenuse never changes, even though your reference angle may change. And so then we'll look at this, we'll do orange and blue. So blue, put the little person in there, they look across, and so when I'm dealing with the blue, which is E, I'll have different ratios than when I look at D, which is orange. And here's my opposite, here's my adjacent. And so blue versus orange, here we go. The sine, might want to write down what that sine is, which is opposite over hypotenuse. This is adjacent over hypotenuse. This is opposite over adjacent. And I'm going through, so I'm looking at D. D is in orange. Opposite is 4. My hypotenuse is 7. The adjacent in orange is square root 33. The opposite is 7. And then opposite over adjacent is 4 square root 33. And again, We don't always do this, but you should rationalize anytime you have a square root in the denominator. There it is. Okay, now I'm looking at the blue. This is square root 33 over 7, because that's my opposite over my adjacent. My hypotenuse, my adjacent is 4 over 7. And this time I'm going to have opposite square root 33 over the adjacent, which is 4. Okay, take a moment, think about that. Pause. What patterns are you beginning to see? What connections can you make? What never changes? How does that impact my problem solving? Again, we'll go with, let's do X as an orange. So your little person, this becomes your opposite when I'm dealing with the orange. This becomes my adjacent when I'm dealing with the orange. This is my hypotenuse. When I'm looking at the blue or Y, this becomes my opposite. This becomes my adjacent. And again, colors really help keep you organized. Otherwise, you're crossing things out, as you saw earlier. And let's begin. So angle X is in orange. So I'm looking at the opposite. I see that it's 1. My hypotenuse is square root 10. My adjacent is 3. My hypotenuse is square root 10. My opposite is 1. My adjacent is 3. My opposite is 3, square root 10. Opposite or adjacent is 1, square root 10, and then 3 over 1, which in test form you might see just a 3. So there's a lot of things going on here. Be very, very careful. Trig is all about how organized you really become, and as organized as you can possibly be, that's going to maximize your opportunity to do well in this course. Okay, we'll just give you one last one. Again, I told you that you would see Greek letters, and so this one's alpha, this one's beta, and again, they're just Greek letters, often used as variables for the angles, to represent angles. So just get used to it. Don't let that be the barrier to your success. So let's look at alpha. We'll put alpha as person in blue. So this is the opposite. Here's the adjacent. Again, remember adjacent means next to, and your hypotenuse is here. Beta we'll put in orange. This is opposite. This is adjacent, and again, the hypotenuse does not change just because you change your reference angle. It's always the thing across from 90 degrees, and that can help you stay organized. Sine is opposite over hypotenuse. Again, I really stress how important it is to make sure you have your labels each time. It keeps you organized, and this unit is really all about making sure that you're organized and keeping things straight. So I circled beta in orange. I have the orange pens. I'm going to do everything in orange. Opposite is 4. The hypotenuse is 6. Adjacent is 2 square root 5 over 6. And then tangent is opposite, which is 4. Oop, I rewrote so opposite is 4 over adjacent is 2 radical 5. You may see this simplified to 2 over square root 5. The last thing is opposite is 2 square root 5 over 6, 4 over 6, and opposite is 2 square root 5 over 4, which you also may see as 5 over 2. Okay, so again, your takeaways: making sure you stay organized, being able to label your triangle, not getting confused when they switch the reference angle on you, which they will often do. Use highlighters, colors, whatever the case may be, different notations. And trig can become not a fearful part of geometry, but one that is very consistent problem-solving strategy for you. Thank you for your time.